Welcome. In this podcast, we're going to learn to identify trig ratios for acute angles in right triangles. So a warm up here, what's the relationship between the three triangles? Notice that all three of these triangles are right triangles. And we know that they're right triangles because they have a right angle, and we know that all right angles are congruent. Right? They all measure 90 degrees. Notice also that each of these triangles has a 37-degree angle, and all 37-degree angles are congruent. All right, so our triangles here are similar to one another because they've got two corresponding angles that are congruent. So the triangles are similar. Using angle, angle, triangle similarity postulate. Now, not only did we know two angle measures, and actually if we wanted to, we could have found the third angles, right? Angles in a triangle add to 180, and so we have a 90-degree angle and a 37-degree angle. And so if we take 180 and we subtract 90 plus 37, we have 180 minus 127, right? And so that means that the other corresponding angles are going to be 53 degrees. So technically, we know three corresponding pairs of angles are congruent, right? That's why it only takes two for a triangle. Because in a triangle, if two of the angles are congruent, well, there's the same amount left for the third angle there, and that's the third angle theorem. But we also knew the side measures. So we're going to compare the small side, the short side in the small triangle, and the medium side in the small triangle, and the short side in the medium triangle, and the medium side in the medium triangle, and the short side in the large triangle, and the medium side in the large triangle, and see what we get. So we're going to reduce the following. Right? So notice all of these are the short side and the medium side, or sometimes when we're talking about right triangle, because we call the sides legs, we might call it the short leg and the long leg, because the other one would be the hypotenuse, right? So this would be short, this would be long leg, this would be hypotenuse. This would be short leg, long leg, hypotenuse, short leg, long leg, hypotenuse. All right, so we have short leg and long leg from the large triangle, short leg and long leg from the medium, and short leg and long leg from the small triangle. And when we reduce, well, we can't do any reducing with 3/4, right? That's as reduced as it gets. But we could reduce the other two. So if we reduce 6/8, they're both divisible by 2. 6 divided by 2 is 3, and 8 divided by 2 is 4. And 9 and 12 are also reducible. They're both divisible by 3. 9 divided by 3 is 3, and 12 divided by 3 is 4. Right? So notice that the sides, when I compare two pairs of corresponding sides, they're in the same ratio. And that'll be important later on. So corresponding sides, and actually put this in your notes somewhere. Corresponding sides, you don't have to write anything else down, just this, what I'm writing right now. Corresponding sides of similar triangles are in the same ratio. So even though the triangles are not the same size, because they're similar, they're in the same ratio, right? So you don't have to be congruent to have the sides be in the same ratio. You just have to be similar, right? And that's what similar triangles are. They're proportional, so their sides are in the same ratio as other triangles that are similar to it. All right, so this is just a little warm-up, and it'll come into play with some other things we look at in this particular lesson. But let's learn a little bit more about what trig ratios are. All right, so trigonometry, and you can just kind of listen along. So trigonometry, from the Greek triangle plus measure, so the trig part means triangle, and the metry means measure, is a branch of mathematics that deals with triangles, particularly right triangles. And all the triangles that we're going to be working with in this lesson are going to be right triangles. Trigonometry deals with relationships between the sides and angles of triangles and uses ratios to describe those relationships. Right? And we know about working with ratios, right? We just did that with similar triangles. Trigonometry was used in surveying, astronomy, and navigation. Both astronomers and sailors scanning the skies and the seas often needed to calculate distances not directly measurable. They applied certain basic rules about the relationships between the sides and angles of triangles. The Egyptians used these relationships in land surveying and when building the pyramids. Babylonian astronomers related angles to arcs of circles to study the earth and measure distances to nearby stars. Trigonometry is used in the fields of engineering, cartography, medical imaging, and other fields. Radio waves are trigonometric functions graphed. And very interestingly about the Egyptians and the Babylonians and astronomers and sailors scanning the skies and seas, back when they started using trigonometry, they did not have a calculator. So they did this all by hand. Right? But we're going to be using a calculator to help us out. All right, so you need to learn some vocabulary words first. So trigonometric ratios. A trigonometric ratio, so first of all, what is a trigonometric ratio? It's a ratio of the lengths of two sides of a right triangle. By the angle-angle similarity postulate, hey, that's what we used at the beginning of this lesson. A right triangle with a given acute angle is similar to every other triangle with the same acute angle measure. In a right triangle, one angle is a right angle, and the side across from this angle is called the hypotenuse. The two sides which form the right angle are called the legs of the right triangle, right? We had a short leg and a long leg. And we're going to be labeling sides of triangles and angles of triangles a certain way. Right? So, first of all, labeling the sides of triangles, the sides and angles of triangles. Angles are going to be labeled using capital letters, just like before. Nothing new about that. But we're not going to use two letters to label sides. We want to have just one letter, because that letter is going to be a variable. And we don't want just any variable, we want a very specific variable. So very important, the sides will be labeled using small letters, right, lowercase. So when we say small letters, we don't mean little capital letters, we mean lowercase. Letters of the opposite angle. So notice in the diagram here, we have angle A. Opposite angle A on the other side of the triangle is side A. And now let's look at, color code here, let's look at angle B. Here's angle B. Opposite angle B on the other side of the triangle is side B. And finally, we have angle C. And angle C is the right angle. So opposite angle C on the other side of the triangle, we have side C. And because side C is opposite the right angle, this is the hypotenuse. The other two sides are legs, but we're going to refer to these legs in a very specific way. Right? So this is a leg, and this is a leg. Right? And then, so the sides that are not opposite the right angle, they're the legs of the triangle. And then, of course, the side opposite the right angle, that's the hypotenuse. All right, so first of all, you have to know how to label your sides. Right? If you label them incorrectly, you're not going to be solving correctly. Can't remember if I had anything important here. Oh, this will be a multiple choice question later on. That's why it's covered up. You'll see that online. So multiple choice question to see if you can label a triangle correctly. All right, so let's look at the right triangle below. The legs are defined as either opposite or adjacent. Opposite and adjacent are position words, just like left and right. And the leg that's opposite and the leg that's adjacent depends on one's point of view. For instance, when you're looking at someone face to face, objects to your right are to their left, and vice versa. Whether a side is adjacent or opposite depends on the angle's point of view. So opposite and adjacent from angle A's point of view is shown below. Notice that opposite angle A is side A. So side A is opposite angle A. The other side, the one that's not opposite, is side B, right? That's the other leg in the triangle. It's not opposite angle A, so it's adjacent. How will you know it's adjacent? It basically makes up part of that angle, right? So angle A there is made up by side B and side C, where those two sides intersect. Why is side B called the adjacent side and not side C? Well, it's because side C is the hypotenuse, right? So because side C is opposite angle C, that's going to be called the hypotenuse, right? So we have two legs. The leg that's opposite an angle, that's the opposite leg. That makes sense, right? Opposite leg should be opposite the angle. And then the other leg of the triangle, which makes up part of that angle, is the adjacent leg. And the hypotenuse is always opposite the right angle. So this is angle A's point of view. It would be different if we take angle B's point of view. So here's angle B's point of view. So now it's side B that's the opposite, right? Because that's the one that's on the opposite side of the triangle. Making up part of angle B is angle A. That's adjacent, side A. So side A is the adjacent leg, right? Because it's not opposite, and it makes up part of angle B. Side B is across the triangle. It's the opposite side. And of course, side C, that's always the hypotenuse. So for this triangle, C is the right angle and C is the hypotenuse. And A and B are the legs. But which is the opposite leg and which is the adjacent leg will depend on the acute angle that you want to work with. If you're interested in angle A, like we were in the last problem, then side A is the opposite leg and B is the adjacent leg. If you're working with acute angle B, like we see in this diagram, then A is the adjacent leg and B is the opposite leg. Regardless of position, the hypotenuse is always across the right angle. So hypotenuse doesn't depend on anyone's point of view. It is always located across the right angle. So that's another multiple choice question for you. There we go. So a couple little multiple choice questions. Can you identify opposite and adjacent? And determine whether the triangle is labeled correctly. All right, so now we're going to learn about trig ratios. There are 6 trigonometric ratios for each acute angle in a right triangle. A trigonometric ratio is the ratio of the two lengths of a right triangle. We're going to learn about 3, tangent, sine, and cosine. And they're abbreviated tan, T-A-N, S-I-N for sine, and C-O-S for cosine, respectively. We use trig ratios to find missing sides and angles in right triangles using 2 pieces of information, 2 sides or a side and an angle. If what we know is 2 sides, we can also use Pythagorean theorem to find a third side given 2 sides. Right? So I'm going to end this podcast now, and we're going to pick up and learn a little bit about our first trig ratio, and that is tangent. Bye for now.